yesterday we have discussed. Now we will go further. We have calculated only for two elements case, two antennas case. Now we are going for n elements. Now I will consider n elements, n antennas we are placing side by side with uh, the the distance of separation between these two antennas are similar. Let us say the distance is, assume, let us say this is the d. The d may be lambda by 2 lambda or 2 lambda also you can take. Okay, for our convenience purpose we are using d is equal to lambda by 2, which is a simple case. Now here here I am assuming the phase angle between two successive elements. See here, this is 0 psi 0 j psi, this is 1 j psi. What is the difference between, what is the phase angle difference between these two? This is psi only. Here see here 1 psi, say 2 psi. Okay, what is the phase difference between these two signals? Here also psi. Okay, are you understand? Earlier I am taking minus psi by 2 plus psi by 2, that is for mathematical convenience. Here the phase angle is psi only. Okay, here, okay, we are assuming that here also the path, because of the path difference there is a phase angle. Okay, here also the phase difference between the two successive antennas, here also psi. You have to understand this point. If you understand this point, some rest of the things are very easy only. You can understand. See here, the resultant electric field intensity at the observation point P is the electric field intensity due to the first antenna, second antenna, third antenna, like that, n antennas. Okay, all the antennas we are giving the same input. See here, what is you are doing here? We are considering array of n elements with equal amplitude and spacing. Here equal amplitude and equal phase also we are giving the same phase. Okay, first case, this is broadside array case. Broadside array case, in broadside array case, the radiation is maximum perpendicular to the antenna axis. You have to remember that. Okay, now see here, for all the antennas we are giving the same input in magnitude and phase. We are giving the same input. That's why E0 is equal to E1 is equal to E2 is equal to En minus 1. 0 to n minus 1, we are having n elements, right? Okay, 0 to n minus 1, total n elements and antennas we are feeding with the same input signal. Now what we are doing? We are doing with simple calculations here. Okay, here you can easily understand. Now total ET is equal to the magnitude of all these electric field intensities are similar. That's why I have taken out the common E0, and this is only, see, first one is e power 0 psi. 0 psi, e power 0 is equal to anything power 0 is equal to 1. That's why this is 1 plus e power j psi 2 j psi plus or plus dash 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 e power n minus 1 j psi. Now we are simplifying this equation. Okay, we are converting it to a familiar or easy way. Okay, for that purpose we are multiplying the above equation on both sides with e power j psi. Now multiply with e power j psi. Okay, here also e power j psi will get. Now last term is e power n j n psi. Okay, now subtract equation 2 from equation 1. But you are getting, subtract this, all the terms are eliminated except the first term and this last term. Remaining all terms will be cancelled. Now we will get, okay, now we will get see here, this is the ET 1 minus e power minus j psi is equal to E0, right? This is E0 1 minus e power 1 minus e power jn psi. Okay, psi. And now we can write ET is equal to, if you send this 1 minus e power j psi in this side, will get this way. Here also further we are doing some simplification. Here we are writing e power j n psi is equal to e power j n psi by 2 into e power j n psi by 2. Okay. Now if you bring out the e power j n psi by 2 outside, here you will get e power minus j n psi by 2 minus e power j n psi by 2. Similarly, do the denominator term also we are writing 1 minus e power j psi by 2 into e power j psi by 2 is equal to e naught. See, now e power j n psi by 2, e power j psi by 2, we are getting this equation. See here, this is looking like e power j theta minus e power minus j theta. If you change these two terms, okay, that negative terms will get cancelled. There is no problem. Now, see, this equal to e power j n psi by 2, e power j psi by 2. Okay, now I am writing this equation as e power j theta minus e power minus j theta. Here n is there, here n is not there. That's all. Okay, see next slide. Now, this is nothing but e power j n psi minus e power minus j n psi by 2, right? This is nothing but what is the 2j times of 2j times of sine theta. Okay, here also 2j times of sine psi by 2. Here 2j times of sine n psi by 2. The 2j will get cancelled. Okay, now here this term will become, if you bring this denominator, okay, upside, okay, right? Now this will become e power minus j psi by 2. Okay, now if you take the common terms, okay, now we are getting this is n psi minus psi, right? N psi minus psi. Therefore, if you bring out the psi, n minus 1 by 2 j into psi. And this is sin n psi by 2 and this is sin psi by 2. Okay. For n elements case, if you are using n antennas, the resultant electric field intensity is equal to E naught. Okay, this is, suppose we here I am taking the only the magnitude of this one. Okay, the magnitude of this e power j, this term is 1. That's why you can write sin n psi by 2 divided by n psi by 2. This is the resultant electric field intensity. By using this expression, we can able to find out the here I mentioned some properties. Okay, direction of main lobe, magnitude of major lobe. Okay, okay, if you arrive at this point, from here onwards it is very easy. Okay, okay, in your main examination point of view also, this is very direct question. Okay, in every question paper, okay, BSA or broadside or end fire array, they will ask questions. Okay, in mid exams also will ask one question from this also. Okay, now we'll see one by one property. First one is direction of the main lobe. Okay, direction of the main lobe. Okay, in case of broadside array, the field is maximum. Okay, we are talking about the broadside array case. In broadside array case, the radiation is maximum in the direction perpendicular to the axis or normal to the axis. Therefore, the condition for the maximum field at point P is given by psi is equal to 0. Okay. Now, substitute psi is equal to 0. What is psi? Psi is equal to BD cos pi is equal to 0. Okay. Now, BD cos pi is equal to 0. That's why cos pi maximum is equal to, when the cos term will 0 will become 0 at 90 degrees and 270 degrees. Okay, pi is equal to 90 degrees and pi is equal to 270 degrees are called the directions of principal maxima. Principal maxima means main lobe. Okay. Similarly, if you want to calculate the magnitude of, in 10 minutes the session will go into close. Okay. After 5 minutes, I will take the attendance. Okay, please try to concentrate here. The magnitude of major lobe or main lobe, we know that the maximum radiation occurs when psi is equal to 0. If you substitute psi is equal to 0 in the expression, okay, the magnitude of the major lobe, okay, what is the expression for the electric field intensity magnitude? This is the ET. Now, ET by E naught, if you take ET by E naught, when psi tends to 0, this is equal to limit psi tends to 0, sin n psi by 2 divided by sin psi by 2. Okay, if you substitute 0 by 0, this is undefined. Therefore, we will use the L'Hospital's rule. Okay, by applying L'Hospital's rule, we will differentiate the numerator term and denominator term. Therefore, we are getting n here. If you differentiate this, we'll get n cos n psi by 2. If you differentiate this, we'll get cos psi by 2. Now, substitute psi is equal to 0. Here we are having n term. Okay. The magnitude of the main lobe is n. What is the n here? N is the total number of elements in the antenna array. Okay. If increase the number of elements, the magnitude of the major lobe will increase. Okay. That you have to understand. Next one is minima direction of side lobe. Okay. Now we are talking about the side lobes. We know this expression. Okay. The condition for minima is given by, what is the condition for minima? Minimum value. When this will become minimum? When this will become minimum? Okay. Then this is a constant. Psi is a constant, right? This is n. Okay. Now, when this term will become 0, then only this will become 0. That's the reason here you have to. The condition for minima is sin n psi by 2 is equal to 0, provided sin psi by 2 is not equal to 0. If this is also between 0 means this is undefined. Okay, this should not be 0. Now substitute in this equation. Okay, apply sin inverse on both sides of these equations. Okay, n psi by 2 is equal to, okay, when the sign term will become 0, plus or minus m pi. If m is equal to 0, sin 0 0. Okay, if m is equal to, if pi, sin pi is equal to also 0. Okay, therefore you can write this equation, substitute psi is equal to bd cos pi. Okay, here n is the number of elements, m is the integer value, d is the spacing between the elements, and the lambda is the wavelength. Okay, now you substitute the psi value in the above equation, we are getting this way. Okay, we know that the beta is the phase constant 2 pi by lambda. Simple mathematical calculations, you can understand. You can please try to solve this equation. Okay, you will get pi minimum is equal to cos inverse of plus or minus m into lambda by n into d. Here, for different values of d, we will get the different phi values. Okay. Okay, this is the expression for the minima direction. Next, direction of maxima. Okay, direction of maxima. When this will become maximum, n psi by 2 is equal to plus or minus 1, provided sin psi by 2 is not equal to 0. Now substitute here in this equation. Now n psi by 2 is equal to sin inverse of plus or minus 1. When this will become 1, this is pi by 2, 3 pi by 2, and 5 pi by 2. Now substitute here. Sin is, therefore this equal to this. This 2 and this 2 will get cancelled. This n will get this side. Pi by n will get psi is equal to this one. Now simplify this equation by substituting this psi value. Psi is equal to bd cos phi. B is the 2, beta is the 2 pi by lambda. Here for this maximum, direction of maxima, we are getting this expression. Okay. Here if you substitute d value, different values of d, we can able to calculate the phi maximum value. Similarly, the beam width of major lobe. Okay, the beam width of the major lobe. The angle between first nulls is called the beam width of broadside array. Okay, the angle between the first nulls is here 2 lambda by L. Okay, that's why this is the first null beam width. Okay, the half of the first null beam width is called the half power beam width. We already know these things. Okay. Okay. Okay, this is the half power beam width. Similarly, okay, this is a same expression, half power beam width. So this beam width for major lobe, that is first null beam width. and this is the half power beam width. Half power beam width is equal to first null beam width divided by 2. That's why we are getting lambda by L. Okay. What is lambda? What is lambda? Lambda is the wavelength. What is the L? L is the length of the antenna. Okay. Similarly, directivity also. For broadside array, the directivity is U maximum by U average, that is equal to 2 into L by lambda. We already solved these equations in earlier case. Okay, that's why directly I am writing here. Okay, if you see the radiation pattern of this antenna, okay, this is looking like this. Okay, see here, I have plotted here how many antennas I are using. Actually, 6 have 8 elements are. This is not 8 elements. Actually, it's a 4 elements. I think the broadside array are having n elements. Okay, n elements. The radiation pattern is looking like this. Okay, next, similarly, we will take the. We have some problems are there. Okay, I have already shared this slide. Okay, before discussing about the end-fire array, we are having some small topic is there, pattern multiplication. In next class, I will discuss the pattern multiplication. Please go through these slides. We have how to take. Can I take the screenshots?